Hello everyone, welcome to this video. So in this video we will discuss problem C almost or multiples which comes in Codeforces Round 836. So in this problem given two integers n and x, and we have to build a permutation of p of length n, and a permutation p of length n is called funny if pi is a multiple of I for all elements from 1 to n minus 1, and Pn should be equal to 1 and P of 1 should be equal to x. It means at the first position of the permutation we have to put an element x which will be given to us, and at the last index of the permutation we have to put 1, and all elements from 1 to n minus 1 should be a multiple of their indexes, respective indexes. And one more condition is given here: if such permutation exists, then we have to print the permutations which is lexicographically minimum funny permutations, and if that such type of permutation doesn't exist, then we have to print -1, as here it is given for each test case. If answer exists, then output and distinct integers, otherwise output -1. So let's see the test case 1. Here the size of permutation is 3, and the value of x is also 3. So we have to put x at first position. So as the conditions are given, the output is also like similar, and p of 1 is 3 and 3 is a multiple of 1, and p2 is, the value of p2 is 2 and 2 is a multiple of 2, and at the end we have 1 is printed. So let's see, go on the whiteboard. So let's take another example. Let's say the size of permutation is 10, and we will choose the value of x one by one. So let's start the value of x take from 2. Let us consider the value of x is 2. So first of all we have to find if we can build a permutations of such type or not. So at first index we will simply put 2, and at the last index we have to put always 1. So at the first index we will put the value of x, and at the second index what we have to put, we have to put another element which is not equal to 2, and that element should be a multiple of 2. So what we can put here, we can put here 4, we can put here 6, we can put here 8, we can put here 10, but the permutation should be lexicographically smaller. So we have to put here only 4, we can't put here 6 because that will not be a lexicographically smaller. So at third position we will put 3, at fourth position we will put we can put 6. No, we can't put 6 because 6 is not a, because 4 is not a multiple of 6 is not a multiple of 4. Okay, so we will put here 8. At fourth position we will put 8. At 5 we will put 5, similar. At 6 we will put 6. At 7 we will put 7, and at 8 we, what we will put, we can't put here anything because there is no element after 8 which is a multiple of 8. So in this condition, when x value, the value of x is 2, the output should be -1, but the output will not be -1. Why? I will tell you here. Because uh, if you put here 4 at second index and here 8, then output should be -1, but the permutation exists. How we know the permutation exists? At index 2 we can simply put 10. If we put 10 here, then we can say, yeah, 10 is a multiple of 2. So at third position we can put 3, at fourth we can simply put 4, 5, at fifth position we can put 5. So they all will be similar, but at the second position we will put 2. So when the value of x is 2, the answer will be this. Let's take another value of x is 3. So if you take the value of x3, then we have to write 3 at first index. So we will put 3 here, and at second position we will put 2, and at third index what we can put, we can put 6, yeah, we can put 9, but we have to write here 6 because 6 is smaller than 9. And at 4 same at 6th position we what we put, we can't write here anything from 7 to 10 because there is no element which satisfy the condition. So when x value of x is 3, the output will be -1. So when x is 3 -1, when x is 4, similarly you can try 4x equal to 4, the answer also will be -1. And when value of x is 5, the answer exists. How the answer exists? Let's see. So when the value of x is 5, we will simply put 5 at first index, and at 2 we will put 2, at 3 we will write 3, 4 at the value of 4 we will be write 4. But at this position what we will write, because 5 is written at the first index, so we have to write the next value multiple of 5, which is 10. So here we will write 10, and at 6th index we will 6, 7, 8, 9 similarly. So we can say when the value of x is 2 and when the value of x is 5, the answer exist. So how can we say that the answer exists only for x equal to 2 and x equal to 5? Because as you can see, when we take 4 we have to write here 4, and at the position 4th we have to write here 8. So here we write 8 when x equal to 4, and what we can write here, 8 at the 8th index we can't write here anything because the next multiple of 8 will be 16, and which is beyond the value of n. So here's one more thing come, that the value of x should be a factor of n. So we can say, yeah, 2 and 5 both are factors of n. So if these conditions come, that uh, the value of x which is given to us is a factor of 10, then simply we can say, yeah, the answer exists. If the value of x is not a factor of n, then we can say, yeah, answer doesn't exist. We have to simply print at this condition -1. So let's see another test case. So in this example, the value of n is 50 and the value of x is 5. So we can say that, yeah, we have to put the value 5 at first index, and we have to make this permutation uh, funny. So as I have told you, we have to first check if that permutation could be made funny or not. So for that condition, we have to find the factors of n. So the factor of 50 is 1, 2, 5, 10, 25 and 50. If the value of x lie in these values, then we can say, yeah, answer always exists. If it doesn't, then you have to simply print -1. So as you can see, 5 is present here. So we will write 5 at first index, and at the second, third, fourth, these value will be same. And at the 5th index, what we can write? Uh, we can write here 10. Then at 10th index, we can write 20. Suppose 20 lie here, and at 20, what we can write? 40. But at 40, what we can write? We can't write here 50 because 50 is not a multiple of 40. And the nearest multiple of 40 is 80, which is beyond the value of n. So we have to make our approach exactly such that answer exists. So at this value, at this index 5, we can't randomly write the next multiple which is nearest to 5. But as you can see, we have to put the value of index 5 which is nearest to in this array. Okay, so the nearest value of 5 is 10. So we will write here 10, and at 6, 7, 8, 9 these will be same, and at the 10th position which is present in this array, which is present in the factor of n, we have to write the nearest value which is a multiple of 10. So we will check if 25 is a multiple of 10. No, it is not a multiple of 10. So this condition fail. We will check to the next value. So we will check if 50 is a multiple of 10. Yeah, 50 is a multiple of 10. We will write here 50. Okay. And the rest values will be same. And we will check 25. 25 is not used before. So 25 will be similar. And all these values will be same. So that's all the logic of this problem. So let's move on the code section. As you can see, I have taken input n and x, and I put the value all factors of n in a set. So you can see I have inserted all the values, all the factors of n. So now I have put it all the values which are present in set S into a vector v, and in another set S1. I will tell you now why I have used these two data structures. So first of all, I will check if the value of x is not present in that set, then we can say that the such type of permutations will never exist. Then we will print -1. Otherwise, at first position we have to print the value of x. So I have printed here x, and at the last value we have to print 1. So I have printed 1 here. So I have started a for loop from 1 to n. So if the value of I is less than x, so as you can see, if I the value of I as 2, 3, 4 is less than x, we will simply print I. So here I have simply print I, as you can see. If it is not, we will go in the else condition, and these conditions come if I is greater than x, greater than equal to x, and s1 dot find I equal not equal to s1 dot end. It means I have checked if the value of I is present in that list, in this vector, or you can say set. If the value of I is present here, then we will move in this loop. So if such value exists, then we will come here, and if I equal to s, then simply we will erase that value, and we will start from 0 to v dot size. Why we start from 0 to v dot size? Because as you can see, we have to put the next value of 5 which is present in this condition in this array, and which is also a fact multiple of 5. So I check here the next value of v dot size. If v dot size v of I v of j mod I equal to 0, and we will check if that element is present in the set or not. If that element is present, but we will remove uh, then we will remove that element after printing that. As you can see, at fifth index we will print 10, and we will remove 10 from here. So if such conditions exist, then we will change the value of k, and k will be true here, and we will break from here. And here we will check if such conditions never exist. So we will not move in this loop. So we will simply print here I, and you can see here if these two conditions will not occur, then we will print here I. So that's all from my side. If you have any comment, if you have any doubt, then please ask in the comment section. Thank you guys. Bye bye. Take care.